Morning guys! Today we're going to take a look at page 12 of the Unit 4 Classwork pack. Now the problems that we're going to take a look at are simply the algebraic applications of the converse theorems. In other words, it's pretty much exactly the same thing we did like maybe 3 videos ago, where we're going to have to set up two equations and either set two things equal or add two things together and set it equal to 180. The only difference this time is just what I'm using it for. Previously, I was actually given parallel lines and asked, well, what do I know about the angle types? Now, I'm asked, well, given this, what would have to be true about these angles to make the lines parallel? So the equations are exactly the same, they're just trying to make it kind of extra complicated for you. Alright, but nothing to be too scared of. Let's take a look together at page 12, example number 1. Alright? Example number 1. I think many of you will be pleasantly surprised just how easy this is. Okay? Alright, so they give me two angles here. They give me 10x minus 23, and they give me 137. Okay. Here's how to do this in a nutshell. Step 1. What angle types do we have? Well, I'm seeing two angles that are on opposite sides of a transversal, and they also happen to be on the interior, meaning in between these two lines. What that means is that I have alternate interior angles. So what I'm going to say is that the converse I'm using is the converse of alternate interior angles. Mind blown, right? And thus, what do you guys know about alternate interior angles? They are congruent. So therefore, all I got to do here, guys, is set up an equation. 2 steps, right? So I would add 23 to both sides. Please, for the love of all that's good and holy, do not use a calculator, okay? And divide both sides by 10, and I get x equals 16. Bam. Done. All right. Let's take a look at one more example just to make sure, all right? And that one will be example number 3. So example number 3, again, you guys gotta be prepared that a lot of times on a test or whatever the case might be, they're just gonna try to be nasty. And what do I mean by that? Well, they're gonna like to rotate diagrams just to kind of psych you out. Don't be deceived. Don't let them get under your skin, right? Show them who's boss. Okay, so this is 96, and this is 6x minus 30, right? Okay, so in order to do this properly, I need you guys, I mean, my neck's kind of hurting right now, so I don't really want to do that, but I want you to look at this diagram sideways. All right, so let's look at it sideways together. Okay, so notice that these two angles are on the same side of this transversal, and they actually are interior, in other words, in between those two lines. Well, if they're on the same side of the interior, hint, hint, nudge, nudge, that means they are same side interior angles. So the converse that I'm going to use is this. Converse of, you could say consecutive interior if you wish, or I could say converse of same side interior. Whatever works for you, okay? Now here's the thing. What you got to remember from earlier in this unit is which category these fall under. Are these two angles congruent or are they supplementary? If you refer back to your notes, you'll find that they are in fact supplementary, which means they add up to, anyone? 180. So therefore, here's my equation. 96 plus 6x minus 30 equals 180. A gentle reminder to everybody to combine like terms. The 96 and the minus 30 are like terms because they're both constants and they're on the same side of the equal sign. So 96 minus 30 gives me 66. Yikes, too many 6's in this problem, don't you think? Ay. Okay, then I'm gonna subtract 66 from both sides. Okay, let's make sure I remember how to subtract. That's gonna become a 10 and I borrow over here. So 6x equals 114. Yeah, okay, I do know how to subtract. And then I'm gonna just divide both sides by 6. Let's see what I get. So 6 into 114 goes in once, minus 6, 5, 4, 9. So x equals 19. All right. Now, there's one more thing I'm going to show you guys, and the notes are going to try to give it a weird name, but But what I'm going to show you is that it's really exactly the same thing we've been doing. They're just being extra. Okay? So can you guys take a look with me at page 14, please? I want you to take a look at page 14 with me, and I want to take a look at example 13. So page 14, example 13. Oh, lordy, lordy, lordy. Okay, so here's a parallel line. Here's another parallel line, I think. Yes, they gave me arrows. And I'm going to draw a transversal going this way, okay? Do, do, do. Five x plus 4y. And they're going to say this is 6y. Okay? Okay, so long story short, people, they're going to try to make up something really fancy schmancy called the perpendicular transversal theorem and say, well, because this line is perpendicular to this one, it's also perpendicular to this one. But I don't really care about that, okay? Because they're just being extra. What they're actually saying, without actually saying what they mean, is this. I want you guys to take a look at this angle right here and this angle right here. Do you notice how they're both on the left-hand side of this transversal and they're both below the lines? What that means is that technically speaking, they are nothing other than corresponding angles. So I don't really care if you know lines perpendicular to a transversal theorem. All they're talking about is corresponding angles where you happen to have a 90-degree corresponding angle. Big deal. Okay, so let's see how we're going to do this, okay? Well, this is irritating, right? Because I actually have two variables. So why don't we deal with the one that just has one variable first? If this is 90 degrees, how many degrees would this angle be? Well, because it's a linear pair, they have to add up to 180, and if I've used 90 degrees, there are 90 degrees left for this one. So therefore, if 6x equals 90, I gotta divide both sides through by 6, and I believe x would equal 15. Bam. Easy peasy. Then, what I'm gonna do is I'm gonna take a look over here. This is 90 degrees, which means that this angle over here also has to be 90 degrees because the two form a linear pair. I'm going to substitute the 15 back in, I apologize, not for x, what am I saying? This is 6y. That'll teach me. Let me fix that for you. Sorry about that. Oh my god. Okay, so anyway, I will hang my head in shame. Anyway, let me plug that back in for y. Okay, so when I do that, I'm going to get the following equation. 5x plus 4 times 15 equals 90. Then I'm going to get 5x plus 60 equals 90. From here, oh my gosh. From here, it's a standard two-step equation. I'm going to subtract 60 from both sides. So 5x equals 30. And then divide both sides by 5, and I get x equals 6. So in short, I don't care about perpendicular transversal theorem. The reason I don't care about perpendicular transversal or two lines perpendicular to the same transversal is because it's all really just corresponding angles in disguise. Okay? So if on that notes page you literally just want to write in big letters corresponding angles, be my guest. Okay? Because that is all I care about when it comes to this particular theorem.